discuss about chapter 13.5, which is about the chain rule, okay, which you already studied in calculus 101. But this chain rule is a little different because we are taking the function of two variables. The chain rule, there are two types of chain rule, okay. One is you can apply the chain rule for derivatives. Another one is chain rule for partial derivatives. So the little change in the uh, in in the formula and in the theorem, that for the chain rule for derivatives, okay. So if I say if x is a function of x of t, one variable function, okay, and y is a function of y of t, and they are both differentiable at t, and if z is a function of x and y, it means z depends on two variables x and y, which is also differentiable at the point x and y, which is equal to x of t and y of t. Then the function z represent in terms of t and y of t, okay. So which is also differentiable, and you can write the formula of the chain rule, that is dz over dt, because the function is now we change into the t variables, that is equal to the partial derivative of z with respect to x and dx over dt, plus partial derivative of z with respect to y and dy over dt. So this is the formula for finding the chain rule of any function, okay, for finding the derivative by using the chain rule. And this formula you can only apply when you have a function with two variables, okay. If you have a function with three variables, what will be the formula becomes, like for example, if you have a function w which have three variables x, y, and z, where x is equal to x of t, y is equal to y of t, and z is equal to z of t, then the formula for the chain rule becomes dw by dt is equal to the partial derivative of w with respect to x, dx over dt, plus partial derivative of w with respect to y, dy over dt, plus partial derivative of w with respect to z, dz over dt. So this is the formula when you have the function of three variables, okay. So and the graph will be like this one. Maybe you know about this one, that if z is a function of x and y, and they both are the same function and one function of t, so this is the chain rule, okay. So if z is a function of x, y, and z, x, y, and z, and they all with the same function which is t, So you can find the chain rule between them. So this is the formula for finding the chain rule. Okay, now I will give you one question for the two variables and one question for the three variables. So it will be clear that how you can apply the chain rule for finding the derivatives. Now the question is that you have to suppose, example, suppose that z is equal to x square y, x is equal to t square, y is equal to t power 3. Use chain rule to find dz over dt. Okay, now you should know about the formula for the chain rule. What is the formula for the chain rule? When you have two functions x and y is a function of one variable, so the chain rule is dz over dt, that is equal to partial z over partial x dx over dt plus partial z over partial y dy over dt. Okay, so this is the formula, you write it. Now you need four terms. Okay, first one, what you need, the partial derivative of z with respect to x. Z is given, which is equal to x square y. What is the partial derivative of z with respect to x? What is the partial derivative of z with respect to x? Z is x square y. What is the partial derivative of x square y with respect to x?
2xy.
Yeah, very good. 2xy. Yeah. Then what is the partial derivative of z with respect to y? Partial by
X
partial
squared.
y, x square only. Yes. So that is equal to x square. Now x is given, which is equal to t square. What is the derivative of x, which is t square? That is equal to 2t. Y is given, which is equal to t power 3. So what is the derivative of dy over dt? T power 3, which is equal to 3t power square. Now substitute these values in the formula, because we need partial derivative of z with respect to x. This is x square. Okay, partial derivative of y with respect to z with respect to y, and this is this one and this one. All these four terms we will use in the formula. So what will become that dz over dt, that is equal to partial derivative of z with respect to x, that is equal to what? 2xy. I write 2xy. Dx over dt is equal to what? 2t. I write 2t plus dz over dy, that is equal to what? X square. I write x square. Dy over dt, that is equal to 3t square. Now all the terms will be in terms of t, but you find here x and y, so substitute this value x and y in this one. Okay, so what you will got, that dz over dt, that is equal to 2 times, what is the value of x? That is t square, multiply by y, that is t power 3 into 2t plus x square will become t square whole square into 3t square. Simplify it, you will get 2t power 5 2t plus t power 4 into 3t square, which is equal to 4t power 6 plus 3t power 6, which is equal to 7t power 6. So this is the answer. Okay, understand? Is this clear? This is for the partial derivative when you have two variables. When you have three variables, okay, good. So when you have three variables, how you can find the partial derivative? See, oh, it's very light. More. Okay. Example, that suppose that w is equal to square root of x square plus y square plus z square, and x is a function of x is equal to cosine of theta, y is equal to sine of theta, and z is equal to tangent of theta. Okay, use the chain rule, use the chain rule to find dw by d theta when theta is equal to pi by 4. Okay, now this is the question. Okay, now see, how many variables for the w have? We want to find what? We want to find dw by d theta, right? Okay, how many variables we have for the w, x, y, and z? Okay, so what will be the partial chain rule? That partial derivative of w with respect to x and dx over d theta. Okay, but here you have theta, so you will write theta. Before in the question we have t, so we write t plus partial derivative of w with respect to y dy over d theta plus partial derivative of w with respect to z and dz over d theta. Now we need how many terms? 6 terms. First one is that w is given, which is equal to square root of x square plus y square plus z square. You need to find the partial derivative of w with respect to x. Partial derivative of w with respect to x. So I can write this one equal to x square plus y square plus z square whole power 1 divided by 2. Okay, so what is the derivative of this one? Square root derivative. You remember, for the square root we write 1 divided by 2 times this one, the same thing. Okay, and inside derivative with respect to x, x square derivative is 2x. What is y square derivative with respect to x? 0. What is z square derivative? That is also 0. So this 2 and this 2 cancel. That will give you x divided by, you can also write square root of x square plus y square plus z square. Okay, this is with respect to x. Similarly, you can find the derivative, partial derivative with respect to y. That will be y divided by x square plus y square plus z square. And with respect to z, that will be the same, that is z divided by square root of x square plus y square plus z square. Okay, now we need to find the derivative of x with respect to theta. X is cosine of theta. What is the derivative of cosine? That is minus sine. What is the derivative of sine? That will be cosine. And what is the derivative of tangent of theta? That will be secant square theta. Okay, so substitute all these values in the formula. What you will get? You will get dw over d theta, that is equal to x divided by square root of x square plus y square plus z square into minus sine of theta, minus sine of theta, plus y divided by square root of x square y square plus z square into cosine of theta, plus z divided by x square plus y square plus z square into secant square theta. Okay, now we need in terms of theta, so substitute each and every value in terms of x, y and z in terms of theta. So what is the value of x? X is cosine of theta, and multiply with sine, that will be minus cosine into sine of theta, divided by square root of x square means cosine square theta plus sine square theta plus tangent square theta, plus cosine multiplied by y is what? Sine. So you can also write cosine of theta into sine of theta divided by square root of cosine square theta plus sine square theta plus tangent square theta, and plus z is what? Tangent. Tangent of theta multiplied by secant square theta divided by cosine square theta plus sine square theta plus tangent square theta. Okay, now this value and this value is same, you can cancel because this is minus and this is plus. So what you will left with? You will left with dw by d theta, dw by d theta, that is equal to tangent of theta into secant square theta divided by cosine square theta plus sine square theta plus tangent square theta. Now can you tell me what is cosine square theta into sine square theta? That is equal to what? 1 plus tangent square theta. We also know the formula for 1 plus tangent square theta. That is equal to what? Secant square theta. Okay, and what is the square root of this one? Tangent of theta secant square theta divided by secant of theta. This cancel with this one, so dw by d theta is equal to what? Tangent of theta into secant of theta. Now we need to find, you can also write that is equal to tangent of theta divided by cosine of theta, because 1 over secant is equal to 1 over cosine of theta. Now you need to find the dw by d theta when theta is equal to pi by 4. Okay, so tangent of pi by 4 divided by cosine of pi by 4. Tangent of pi by 4 is equal to 1, and cosine pi by 4 is 1 divided by square root of 2. That is equal to square root of 2. So this is the answer. Okay, so little lengthy. If you know the derivatives, you have to just simplify according to the derivatives and you will get the answer. This is about the chain rule for the derivatives. Okay, so any question about the chain rule of derivatives, you can ask me. Now there is another theorem which is about the chain rule for partial derivatives. Okay, so what is the chain rule of partial derivatives? That if you have any function, if x is a function of x of u and v, two variable function, and y is equal to y of u and v, two variable function, have first order partial derivatives, partial derivatives at the point u and v, and z is a function of x and y, okay, is differentiable at the point x and y, and x and y are the functions of u and v, and y is a function of u and v. Okay, then z will become the function which is x u and v, and y u and v, okay, has first order partial derivatives at the point u and v given by this one. So when you have two partial derivatives, then there will be z is a function with respect to u. You can also find the partial derivative with respect to u, okay, and you can also find the z with respect to v, okay. So there are two formulas you can easily find. One will be the with respect to u. So what will be the formula? That you have to first find the partial derivative of z with respect to x, and the partial derivative of x with respect to u, plus partial derivative of z with respect to y, and partial derivative of y with respect to u. So this is the first formula. The second is with respect to v, z with respect to x, and x with respect to v, z with respect to y, and y with respect to v. So this is the second formula, okay. So this is because you have x in terms of u and v. So first you have to find with respect to u, and then you have to find with respect to v. So if you have three order variables, that for example w is a function, okay, in terms of x and z, and x is equal to x of u and v, y is equal to u and v, y is a function of u and v, okay, and z is a function of u and v, then there will also the two partial derivatives. What will be that? That the partial derivative of w with respect to, first you have to first find with respect to u, and then you have to find the partial derivative with respect to w. What will be that? That partial derivative of w with respect to x, and then x with respect to u, plus the partial derivative of w with respect to y, and y with respect to u, plus partial derivative of w with respect to z, and z with respect to u. Similarly, partial derivative of w with respect to x and x with respect to v, plus partial derivative of w with respect to y and y with respect to v, plus partial derivative of w with respect to z and z with respect to v. So these are the two formulas when you have the three variable function. Now I will give you the example, so that will be clear that how you can find the partial derivatives by using the chain rule, by using the partial derivatives. Okay, now this is the example, that it is given that z is equal to e power xy. Okay, z is a function of x and y, where x is given which is equal to 2u plus v, that x is a function of u and v, and y is given which is equal to u divided by v, also y is a function of u and v. Then you have to find partial derivative of z with respect to u and partial derivative of z with respect to v using the chain rule. Okay, first we will find this one. Okay, for this one we know the what is the formula. Partial derivative of z with respect to u, the formula will be the partial z with respect to x and x with respect to u, plus partial derivative of z with respect to y and y with respect to u. So this is the formula. Okay, now z is given. What is the partial derivative of z with respect to x? Anybody can tell me what is the partial derivative of z with respect to x? And z is e power xy. What is the partial derivative of this one with respect to x? Anybody? The partial derivative will become e power xy is same, and xy derivative with respect to x is y, so it will become y into e power xy. Similarly, you can find the partial derivative with respect to y, that is partial by partial y of e power xy, that is equal to x into e power xy. Okay, so what is the partial derivative of x with respect to u? That is also equal to 2. What is the partial derivative of y with respect to u? That is equal to 1 over v. So substitute these four values in the formula. What you will got, that partial derivative of z with respect to u, that is equal to y into e power xy multiplied by 2 plus x into e power xy multiplied by 1 over v. Now we need everything in terms of u. Okay, u or v you can write. So in terms of this one, that will become, what is the value of v y? That is u divided by v, and 2 you can write here 2 e power xy. X is what? 2u plus v, and y is what? U over v, plus x is 2u divided by 2u plus v, and e power 2u plus v into u divided by v, 1 over v. Simplify it. This term is same in both the terms, this one and this one. So you can take outside e power 2u plus v into u divided by v. So here you will left 2u divided by v, and here you will left 2u plus v into 1 over v. Okay, so you can simplify this, the first term, that is 2u square plus uv divided by v, and this one you can simplify 2u by v plus 2u plus v divided by v, which is equal to e power 2u square plus uv divided by v, and v 2u plus 2u is 4u plus v. So this is the answer. Okay, this is with respect to u. Similarly, you can find with respect to v. So what is with respect to v? The same values, that z is given the same thing, that is e power xy, and x is given which is equal to 2u plus v, and y is given which is equal to u divided by v. Now you have to find the partial derivative of z with respect to v. So what is that formula? That partial derivative of z with respect to x, x with respect to v, plus partial derivative of z with respect to y, and y with respect to v. Okay, so similarly we find the partial derivative of x and y in the last part, which is y into e power xy, and partial derivative of z with respect to y, that is into e power xy. And what is the partial derivative of x with respect to v? That is 1. And partial derivative of y with respect to v, that is equal to minus u divided by v square. Okay, so substitute these values in the formula. What you will got, that partial derivative of z with respect to v, that is equal to y into e power xy, plus multiply by 1, so no need to write, plus x into e power xy multiply by minus u divided by v square. Okay, now substitute the value of x and y in the in this result, that y is u divided by v, e power 2u plus v multiply by u divided by v, plus what is x? 2u plus v, and e power 2u plus v multiply by u divided by v into minus u divided by v square. Okay, so the same value is similar in both the terms, so you can write e power 2u plus v into u divided by v. Okay, so what left? U divided by v plus 2u plus v multiplied by minus u divided by v square. Simplify this one. What you will got? E power 2u square plus vu divided by v, and here you, when you will simplify, you will get uv minus 2u square divided by v square minus uv divided by v square. Okay, so if you want to simplify more, you can simplify, that is equal to e multiplied by 2u square plus uv divided by v whole divided by v square, that is equal to uv minus 2u square minus uv. This uv and this uv cancel, that is equal to e power 2u square plus uv divided by v into minus 2u square divided by v square. Okay, this is just a simplification. Okay, you can simplify according to that. So this is the partial derivatives with respect to v. Okay, so in this case these are the partial derivatives, that if you have z is a function of x and y, okay, and x is a function of u and v, x is a function of u and v, and y is also a function of u and v, then you will apply the partial derivatives of chain rule. Okay, another one, that if you have w is a function of x, y, and z, x, y, and z, and xy is a function of u and v. Okay, then y is a function of u and v, z is a function of u and v. This is different. Another one is different, that if you have w is a function of x, y, and z, and x is a function of three variables, for example rho, theta, and phi, then y is also a function of three variables and z is a function of three variables. So these are all partial derivatives. You have to see that if x, y, and z are the functions of three variables,